Welcome, EV learners, to an exciting journey of knowledge and growth. I am excited to be your guide on this educational adventure. In this course, we will focus on EV chargers, primarily level 1 chargers, and dive deep into the fundamentals and key concepts related to this. So let's get started. Introduction of EV charging. In this video, we will understand the concept of EVSE, Electric Vehicle Supply Equipment, a device that provides the necessary electrical power to charge an electric vehicle. EVSEs are available in different types, including Level 1, Level 2, and Level 3, and offer varying charging speeds and power outputs. Electric vehicle (EV) charging refers to the process of charging the batteries of an electric vehicle, such as a car, motorcycle, or scooter. This is typically done using a charging station, which can be found at a variety of locations like homes, workplaces, public parking lots, and along highways. The increasing popularity of electric vehicles has led to a growing demand for EV charging infrastructure. As more and more people switch to electric vehicles to reduce their carbon footprint and save on fuel costs. Architecture of EV. EVs have approx 90% fewer moving parts than an ICE internal combustion engine vehicle. Here are the key components of an EV. Motor. It provides power to rotate the wheels. It can be DC-AC type. Power electronics. Power electronics control the flow of electrical energy between the battery pack and the electric motor. Onboard charger. The onboard charger is responsible for converting AC, alternating current, power from an external charging station or a regular electrical outlet into DC, direct current, power to charge the battery pack. Charging inlet. The charging inlet is the external interface, or port through which the vehicle is connected to an external power source for charging its battery. Battery junction box. It plays a crucial role in managing and protecting the battery system. Battery pack. It serves as the primary energy storage system, supplying electrical power to the vehicle's electric motor and other electrical components. Overview of EVSE. In this section, we will understand the concept of AC and DC charging in an electric vehicle, so let's start. AC charging. Generally, the power which we received from the electrical grid is AC. To charge an electrical vehicle, this AC power is first converted to the DC power by onboard charger, which is built into the vehicle. AC charging is commonly used for slower charging scenarios, such as overnight charging at home or charging at public AC charging stations. DC charging. DC charging, also known as fast charging, involves supplying DC power directly to the vehicle's battery. Unlike AC charging, there is no need for onboard AC to DC conversion. Instead, DC charging stations provide high-power DC electricity, bypassing the vehicle's onboard charger. This allows for faster charging rates, which significantly reduce the charging times. The right charger. Commercial EVs fleet vehicles like Mahindra e-Verito, Mahindra E2O, Tata Express T, and old Tata Tigor use the GBT connector. Passenger EVs CCS2 and Type 2 are emerging as the charging industry standard. All two-wheelers can be charged using a standard 15-amp socket. Components of EVSE electric vehicle supply equipment. Charging point. This is the primary component of EVSE, which is responsible for delivering electrical power to the electric vehicle's battery. Charging point is usually mounted on a wall or pedestal and contains the power, electronics, and control system needed to regulate the charging process. Connector. The connector is the physical interface used to connect the electric vehicle to the charging station. Several types of connectors are used in EVSE, including 3-pin sockets, Type 2 connectors, CHAdeMO connectors, GBT and CCS connectors, among others. Charging cable. The charging cable connects the charging station to the electric vehicle via the connector. The cable is typically insulated and designed to withstand high current and temperature. Power supply. The power supply provides the electrical power needed to operate the charging station. Depending on the type of charging station, the power supply may be a standard to 30 volt AC. Types of charging station. Charging stations are classified into 3 categories, referred as public charging stations, semi-public charging stations, private charging stations. Public charging station. Public charging stations are owned and operated by various entities, such as governments, utilities, and private companies, and are open to the general public. These charging stations are typically located in public areas like parking lots, shopping centers, and city streets and highways. Semi-public charging station. Semi-public charging stations are owned and operated by organizations that restrict access to the charging station, such as workplaces, apartment buildings, or gated communities. These charging stations are not open to the general public but are accessible to a specific group of users. Private charging station. Private charging stations are owned and operated by individual electric vehicle owners and are typically located at their homes or businesses. These charging stations are not open to the general public and are only accessible to the owner and their guests. EV chargers. There are different types of EV chargers available, ranging from level 1 to level 3 chargers. Level 1 chargers use a standard 230 volt household outlet and provide the slowest charging rate, whereas level 3 chargers, also known as DC fast chargers, are the fastest and can charge an electric vehicle in as little as 30 minutes. AC chargers. AC chargers are typically slower than DC chargers, and they are typically used for charging electric vehicles at home or at workplaces. AC chargers can be used with a standard household electrical outlet, level 1, or with a Type 2 connector that provides a higher level of charging power, level 2. DC chargers. DC chargers, on the other hand, are much faster than AC chargers and typically used for public charging stations along highways and at other high-traffic locations. DC chargers can provide much higher charging power than AC chargers, allowing electric vehicles to charge much more quickly. Quick fact. Ultimately, the type of charger that is best for a given situation depends on a number of factors, including the specific electric vehicle being charged, the available electrical infrastructure, and the charging needs of the user. Level 1. In this video, we will have deep insights about Level 1 chargers, often called as smart charging points. It is technically a 3.3 kilowatt socket with a maximum current of 15 amp. This type of charging point is available both as a universal socket and an industrial socket. Level 1 charging points are best known for charging 2 and 3-wheeler. But very few know that even a 4-wheeler can be easily charged through a 3.3 kilowatts charging point, often termed home charging points because of their ability to be installed easily on the existing domestic circuit. What is the difference between a Level 1 EV charging point and a traditional home socket? So, let's see the differences in the next slides. Protection. Traditional socket doesn't have any protection. In case of any overload condition, the whole circuit trips at home, whereas EV charging point comes with all types of protection, namely overload protection, short circuit protection, surge protection, and power theft protection. It senses any abnormal condition and disconnects the circuit from the mains. thereby protecting both the vehicle and the main circuit. Smart charging. How about seeing real-time charging through an app? EV Charging Point comes with a smart app through which you can start and stop the charging. You can analyze the charging patterns, the last charge details, units consumed, and real-time updates. Power rating. Charging cost. Connector type. Location map. Energy consumed. Smart charging features. Here are few features shown in these images which makes a EV charger smarter from the traditional sockets like charger name, location map, connector type, charging cost, energy consumed. Technical specifications for level 1 charger. It can come with any type of socket, universal or industrial socket. It requires a single-phase AC supply of 220 volt. The max output it can give is 3.3 kilowatts with 15 amp. Following things are required for installation. Cable, drill machine, multimeter, screwdriver, tester. SOP for installation. Check the electricity bill to determine sanctioned load. Here, as per shown the electricity bill, the sanctioned load is 10 kilowatts. Check the consumed load at the home society from which the connection is to be taken. Here is the power rating most commonly used appliances at any household. Here we have taken an example of a household with the appliances shown in the above list. From the table we can see here as the maximum consumed load at a time is 2.77 kilowatts. For calculation purposes and considering the safety, it is recommended to have a buffer of 10% consumed load. Hence for the given scenario the load will be 3.04 kilowatts. Determine the spare load available by subtracting the consumed load from the sanctioned load. As we have seen in the previous example, the total consumed load is 3.04 kilowatts and the sanctioned load is 10 kilowatts. Hence, we can find out the spare load by subtracting the consumed load from the sanctioned load. Sanctioned load 10 kilowatts minus consumed load 3.04 kilowatts is equal to spare load 6.96 kilowatts. As we have sufficient electrical load available, we can proceed for charger installation. Check whether earthing is available. To check the earthing, we will measure voltage or resistance between neutral and earth. It should be ideally 0. So, here we are going to share a video in next slide, which will explain the process to check the earthing. So, today we are going to install level 1 charger at this location. This is the installation location. Here is the parking space available. This is the power source from where the connection has to be taken. We will require single-phase AC supply of 230 volt where earthing must be present. So here is the phase, neutral, and earthing. We will set the multimeter to check the AC voltage. At first, we will check phase and neutral voltage that is shown here around 240 volt. Then we will test phase and earth voltage that is showing close to 240 volt only as it's showing in the multimeter. Afterwards, we will check resistance voltage between neutral and earthing, which should be below 5 ohm and ideally 0 ohm. Here it's showing around 1, which indicates earthing is present and we can proceed for level 1 charger installation. Check the nearest power source from where the connection is to be taken to avoid any power loss and save the wire cost. Check whether the mobile network is available or Wi-Fi is nearby to get real-time updates. Here we can see the change in energy consumption when the charger is connected to Wi-Fi. Most importantly, inspect the place of installation, check whether proper parking is available, and the place is free of any inflammable material. It is always recommended that the charging point should be placed 4 feet above the ground to keep it away from children's reach. For ease of operations, let's prepare a feasibility document which will be handy for you to gather all information at the site. So now, we have come to the conclusion of this training video focused on Level 1 EV charger. We would like to congratulate the participants for completion of this training video and also would like to thank them for their commitment to learning.